So, hello Year 8 and welcome back to the third and final part of your murder mystery. This is obviously Enrichment Week, so see all of these tasks as optional, do them if you're interested and you want to follow through the forensic evidence. And to be fair, if you're not engaged and you don't want to do that, then why are you watching? Because no one's going to make you. So first I just want to thank all of those of you who have been engaged with the material, have tried the experiments, have completed the Google Forms and have emailed me back with photos or information saying actually that you've been enjoying the material. So just some photos here from a few people that they've submitted. You can see Will R there cutting up his plastics to find out which plastics float and which plastics sink. Eve H down there demonstrating that at least one type of plastic there is floating in her bowl of water. Amy doing the blueberry experiments with the lovely range of colours from orangey red through red, purple and probably oil on the right, that sort of greeny yellow colour. And Helen A there doing the experiments to determine which of the powders dissolved and which of the powders didn't. So thank you very much if you did those experiments, but these were some of the photos that were sent to me. Right, with regards to the experiments from the second week, the first question is, which pen finished the note? And I've got two lovely pictures down here from Sophie W and Emily F, and in both cases showing that one of these pens produced a pattern quite similar to the one seen on the note, and I think that the bars above speak for themselves. It is the felt tip pen, the Crayola, that clearly wrote that note. The Sharpie, the Biro, whiteboard markers and acetate pens, if you did them, none of those smeared, but the one that did smear was the felt tip pen with a pattern similar to the one from the note. So, whose fingerprints were on that pen? Well, first I asked you to do a little bit of your own fingerprint analysis, and this is what we saw. As expected, for almost every finger, well, indeed for every finger, loops were the predominant type of feature seen, and about 65% of all fingerprints should be loops, and that looks quite accurate from the data we've got here. The next most common should have been the wall at around 30%, 25 to 30%, and again, looking at the data, the red bar is in many cases about half the height of the blue bar, and finally arches are supposed to be quite rare, with only about 5 to 10% of people having those, and again in some cases like the right ring finger, arches very much in the minority. Also a lot of obvious deltas, which is great because that shows that you guys were being careful when taking your fingerprints. Two examples that were sent to me, Emily F and Sophie W, thank you for those. And if any of you are thinking of committing a crime at any point in the future, you now have both of their fingerprints on record so that you can do a little misdirect for the police. So there you go. Thanks to those two for those pictures. So whose fingerprint was it on the pen? Well, the Sharpie, virtually everybody matching to Reg. The Biro, people matching to Robin and the CSI tech, so one fingerprint of each, well done there. The whiteboard pen was the victim. The OHP pen was Brittany, but many people, if not most of you, identifying that the Crayola, and this was the one that we're interested in, this was used to write the note. This contained the CSI tech's fingerprint, but it also contained Paris's fingerprint. And with any luck, there we go. We can see the prints matching up there, so that bottom print matching up with Paris's fingerprint. So, given all of the evidence, who do you think the suspects are? Well, again, I think the note was pretty damning. that Paris is a likely suspect. She's the only one who you all thought was quite a likely suspect. Still suspicion about the rower, possibly, because of the contents of a shopping bag. Robin, because of the contents of his shopping bag. But Paris, by far and away, the one that you guys are focusing in on as the likely suspect. Now, in the first week, we seemed to identify Robin as the most likely suspect based on the contents of his shopping bag. But during interview, he proved that it wasn't him. So how on earth did that go wrong? Let's go back to our CSI tech to see if he can shed light on the situation. Right, so you're back with me looking at the CCTV evidence because you obviously want to know what went wrong with that. Fair play, hands up, was my fault, but not totally, right? We have no cameras in the shops, nothing looking at the tills themselves. So I was basically working out based on entry and exit data. So if you come around here and have a look at my screen, okay? So here we go. This is what's going on. The suspects arranged in order of the times that they left the shop, and you can see the timestamps down here at the bottom of each photo. And these are the 9 suspects what left the store with a bag for life around the time we're interested in. Now underneath you can see here the till receipt times, so 12:15 and 2 seconds, 10 seconds and so on. And what I've just done is I've matched the people in order of the time they left and the time the till receipts happened. Now we know from credit card receipts that this is definitely right, so this is right, and we know that this is right, and we know that this is right. But the other people, we don't know exactly whether they're matched correctly. For example, let's say that Flip-Flops here, she actually bought her stuff way earlier at 12:15 and 13 seconds and then just hung around for a while. I don't know, maybe doing her makeup or adjusting her flip-flops or something like that. Then maybe actually this person here, Diablo, actually bought his till receipt at this time. So, you know, it may be we haven't got all of these right, and that may explain why Robin here, who was initially identified as the victim, we know that this person here, whoever it was that bought their stuff at 12:15 and 37 seconds, is the person with the suspect bag, but it may be that that wasn't actually Robin. So yeah, you've got a few other suspects there, unfortunately, that may have done it or could have done it based on the evidence we have at the moment. So that was the CSI tech there giving us the rather depressing news that we're not 100% sure who it was that bought the baking soda and the blueberries and whose bag it was that ended up in the landfill site with the murder weapon. But we do have more evidence. Lucky for us, whoever was around Chrissy as she was bleeding ran through the puddle of blood, and we found some bloody footprints, and you can see those up here, one of them in close-up, and they were running away from the scene, and you can see those 1, 2, 3, 4 footprints there highlighted running away from the scene. Now we can use this information to try and help us work out the height of the perpetrator, the person who did it. Because it turns out that the length of your stride or the length of your step is closely related to the height that you are. And as it says up here, for males, for men, if you multiply your height in centimetres by 0.415, you can get roughly how long your step length is. So between the back of one foot to the back of the next foot as you're walking. This is a brisk walk, this wouldn't work for an amble, but let's assume that whoever walked through the blood puddle isn't going to be hanging around. For females, for women, it's very similar. You multiply the height by 0.413 to get the distance, which is very similar, it's just slightly shorter. And again, that would be from the back of one step, with one foot to the back of the other step with the other foot. So what you're going to do here is you need to either print off this chart if you've got one, or quickly sketch it down on a piece of rough paper. We've got our suspects on the left hand side. You're going to re-watch the CCTV evidence and you're going to work out the height to the nearest centimetre of each suspect from that CCTV evidence. So let's say, for example, that Kate was 190 centimetres tall. Well, then her stride length, being a woman, would be 190 times by 0.413, which equals about 78.5 centimetres. Okay, so watch the CCTV evidence, get the height of each suspect, and then work out what their approximate stride length would be. Okay, now you've completed that and you have an approximate stride length. We've put the start of the tape measure here in line with the heel of the first step. You can see the second step here, the third step here, and the fourth step here. So pause the video, go back, match that to the suspects, and see which of our suspects could have been the person who ran through the puddle of blood. So, if you remember, this all started when some operatives at the local landfill centre had a horrible graunching noise coming from one of the industrial shredders, and someone had stuck a bag for life through one of those shredders with something metal. And on closer inspection, it was obvious that that bit of metal contained blood evidence, and that started the link between the bag for life and Chris's murder. Well, we've identified what that is. And that bit of metal is a tyre iron. What is a tyre iron, you may ask? Well, that's a tyre iron. It's something that's used to help you undo the nuts so that when you're changing a car tyre, you can undo the nuts and take off the old car tyre or wheel, and then you can put the new wheel on and you can tighten up the nuts so the wheel won't fall off. Where would you find it? Well, if you look in the back of my police car and notice what a beautiful, clean police car it is, there's often a compartment under the floor of the boot that when you open it up, it'll have the tools that you need to do things like change the car tyre or the car wheel. And if you have a look on the left, you will see that there is a series of tools, including the jack to lift up the car, and one of them is the tyre iron. Well, after your good work last week, linking the pen to Paris, we were fairly certain she had something to do with Chris's murder, so we went and we had a look in her boot. So this is her boot, and we looked underneath the floor, and oh look, there's space for a tyre iron, but there is a missing tyre iron. Now, this is what we call circumstantial evidence. It might point us towards the perpetrator of a crime, but it's not really going to do much in court. We need more. Luckily, our wonderful forensic investigator has some evidence for us. Back again. I'm starting to think you fancy me. Anyway, we'll better get on having a look at some of this data that's come in from the tyre iron. So if I bring you round here, you can have another look at the stuff that's going on. So this is the air analysis that we got going on here. Right, so when we look at the structure of a human hair, I've got an image down here. The structure of a human hair is a little bit like a pencil that you'd use, in that we've got this kind of coating on the outside, which we call the cuticle, and that's this bit here. And then right down the middle, where you'd find like the lead of the pencil, then, so here, the lead that goes right down the middle of that pencil, that's what we call the medulla. And then the rest of the hair is filled in with this stuff called the cortex, okay? And first thing you got to do is you've got to kind of identify what type of medulla you got. So sometimes you've just got like a pencil lead that you ain't dropped and a continuous medulla, and that's like this hair here. You've just got this continuous line down the middle of it. Sometimes you've got a very regular pattern, so like this one here. I guess that would be like one of those pencils where you pull crayon or the pencil bit out the end and you stick it back in the top. Used to get those a lot at Pizza Express, used to love those. If you've dropped your pencil, it's a bit like this one, fragmented or segmented, and that's like this one here. Sometimes the hair's so dark you just can't actually see whether there's a medulla or not. We'll see an example of those on the next slide. And sometimes, like this hair up here, you ain't got a medulla. And this is kind of useful, but the most important thing is that you don't confuse that medulla down the middle for the pigments, which is what we're going to look at on the next slide. So it's the pigment granules that we're really interested in, because your pigment granules are usually found near the cuticle, so that's kind of on the outside there. So if you've got pigment granules, they're usually kind of on the outside, except in redheads. So in redheads you get kind of like this one here. This is a redhead. You get streaky pigment granules all over the place. This in the middle, right, this is the medulla, so don't get confused with that, but the pigment granules all through the hair, but it's got a definite red tinge, that one. This here, this is a blonde, and so blondes don't have much pigment at all. So this one hasn't got a medulla, that's by the by, but it's not got much pigment, and that's the important thing. Things like this here, this is a sort of a brunette. So you can see like lots of little pigment granules around the edge here, around the end of the hair, and that is a brunette going on there. If you've got things like Asian hair, like this one here, this is an Asian hair, and this is an Asian hair. That's got loads of pigment granules, and sometimes it's got so much pigment you can't really even see through it. So like this one here, we don't even know whether it's got a medulla or not. Often you can kind of tell an African hair because those pigment granules are kind of clustered together into larger lumps. So it tends to have like large lumps of pigment rather than the very, very small spots that you get in a Caucasian hair. Interestingly, if a hair's been bleached and it's not a natural colour, then often it's destroyed an awful lot of the pigment inside, and so the hair kind of looks like a hollow tube almost. You can't see much inside it, and that's often an indication that a hair's been bleached. But the fact we really care is that we can actually use this to work out whether a hair has come from a particular suspect. So if you're looking for Caucasian hair, so that's like Europeans and all, it tends to have small, evenly distributed pigment granules. So you can see here, these are the blondes and this is the brunette and the redheads. You can't really see any big pigment granules in that. African hair, as I said, this is where you tend to get the much bigger pigment granules. So you can really see, like try not to get the medulla if there is one. You can see lots of big pigment granules in this hair and this one as well. So that's not the medulla. This is the medulla right down the centre, but those are big pigment granules. And as I said before, like Asian hair, like these two, often you've got so much pigment in Asian hair you can't even really see what size the granules are or even the medulla. So we can kind of use this to identify what's going on. So the tire iron that we managed to pull out, or the bits of the tire iron we managed to pull out from the landfill centre, there was quite a lot of hair on that tire iron. Given it was inside a bag, we suspect most of these hairs actually came from contact before the landfill centre, and we managed to find these 8 hairs. So given the information on the previous couple of slides, I was hoping you'd be able to help me work out minimum number of different people we're looking at, and whether any of these might even lead us to a suspect. So there you go. What you need to do is just pause the video, have a look at this. If you need to flick back a few seconds, that's fine. See if you can identify the type of hair 1 through 8, and then what you can do, these are our 9 suspects and the victim Chris in the top right, and these are the hair colours of each of our suspects and the victim. Chris, the victim, was a brunette, and we would expect her hair to be on the tire iron given that she was hit with it. Other brunettes include Kate, the rower, and Reg, the train spotter. We've got a couple of blondes, Paris and Princess T, Trinity. We've got a bleached blonde, Brittany the ballerina. Robin's a blonde. We've got a dyed redhead, Soccer Mom. We've got a ginger, Diablo, and we still have no idea what Flip Flops is. So does the hair evidence give you any clues as to who might have been around the tire iron when it was being used to kill Chris? As if that's not enough, back we go to our science tech for the last time to give us the final bit of evidence. Back again. This is just getting embarrassing, isn't it? Alright, last time I'm going to talk you now through DNA evidence, how it's collected, and actually, you know, what we can learn from that, because we got a few good samples off the tire iron and also under the victim's fingernails, and I think this is going to be crucial for working out exactly what's going on with this crime. Okay, bear with. Sounds a bit complicated, but it isn't really. So what we do is we take some sort of DNA sample. It can be a bit of blood, can be semen, can be saliva, can be like skin under the fingernails, basically anything that's got intact DNA from a person. And then we extract the DNA. And as I'm sure you're aware from your biology, the DNA is like the instruction book for the cell, instruction book for the body really. It kind of tells the body what to look like, how to grow, what to do. And everybody has different DNA, and that's why everybody looks different. Well, the clever bit is this. What we do is we cut up the DNA using these things called restriction enzymes. And they cut in really specific places in the DNA, really specific sequences. And this chops the DNA up into lots of different length fragments. Some of them are going to be really quite small, like this one here. Some of them are going to be really quite long, like this one here. But the really clever thing is, because everyone's got different DNA, different sequences of instructions, everybody's DNA gets cut up a little bit differently. And then what we do, it's a bit like that chromatography experiment that you did for me last week with the ink. You basically stick all of these samples onto a spot and then you just run them. So like you had those inks that ran like really far, like was it the blue one that went really, really far? And the other ones, like the red one, didn't go as far, and then some of those black ones didn't move at all. Well, it turns out that the really short fragments move really, really far, but the bigger the fragment is, the less far it moves on this chromatography experiment. So electrophoresis is basically just like a chromatography experiment. And then just we do a little bit of clever jiggery pokery here, and that's just so that we can actually see where the bands are. But when we x-ray them, we can see a sequence of bands from really big stuff up here to really little stuff down here. And on the right, you can see the sort of thing that we've done. So here were the wells all the way up the top, and we've run mum, dad, so this is mum, F is for father, and 2 children. We've run their DNA, and you can see where all the bands were. Yeah, some of them a bit faint. I've had to mark them here in pen, but you can see this pattern, and you can see that each person's got a slightly different pattern of bands. This child and the dad, for example, they've both got a band here, but there's not one there for mum and the other kid. Up here, both kids have got this band that comes from mum, but father doesn't have one, so they both must have got that bit of DNA from their mum. So this is kind of like working out whether or not the DNA's come from mum. So this kid, that bit of DNA's clearly come from mum, and this bit of DNA in this kid's clearly come from the mum, but both of these kids have got this bit of DNA from their dad. And the great thing is, every single person has a completely unique fingerprint, as it's called, of DNA, this sequence of bands. So let's look at it here. Let's say we've got some evidence that we've collected, evidence A. Right, when we're trying to match it to our suspects, there can be missing bands in the evidence. So sometimes, for whatever reason, like there's not enough DNA, so we might not see that band. Like on the previous one, there were some of those bands that were really, really faint. So we might not see one. But what we can't have is we can't have any extra bands. So if, for example, this bit of evidence has got a band here, then yeah, suspect 1 could have done it and suspect 2 could have done it, but there's no band in suspect 3. So it cannot have been suspect 3, right? You can't have any extra bands in your evidence that weren't there in the original sample. So looking down, this band's here. And yeah, sure, it's there in 2 and 3, but that band ain't there in suspect 1. So it can't have been suspect 1 either, because it's got a band in the evidence that isn't there in the original sample, the original suspect. Okay, so it clearly is suspect 2. Now looking down, yeah, there's that band. Yeah, there's that band, but this band's missing. But it's okay. It's all right if there's missing bands in the sample, but you can't have any extra ones. They've got this one, which is there. They've got this one, which is there. And then they've got this one, is that one. But again, these 2 have gone missing. It's got this one, which is that, and these 2, all right? So this is suspect 2. Yeah, it's missing a couple of bands, but it's okay. You're allowed to be missing bands, you just can't have any extras. If we look at evidence B here, well, we can immediately rule out suspect 4 because there's no band there, so it can't have come from suspect 4. We can rule out, in fact, looking at this band, we can rule out all of the suspects. So none of the suspects have that band. So this is telling us that evidence B didn't come from any of these suspects. Although, if we have a look, these 3 match those 3. These 2 match these 2. That one matches that one. And these 3 match these 3. So it's probably a close relative of suspect number 5. Because many of the bands agree there's just that one that's missing, all right? So it might be related to 5. So you probably home in on 5 and maybe see if you can get a warrant for DNA from brothers or so on. Anyway, this is what we got for you guys. So we managed to get DNA off our victim, poor Chris, Reg, Paris, Robin, Brittany, Trinity, Kate and Liz. Obviously don't know who Flip Flops is, so we can't get her DNA. The tire iron, we managed to get 3 samples of DNA from the blood on the tire iron, so that's that. But also, do you remember I said we got some DNA from the skin under the victim's fingernails? So we got that. So what you need to do is you need to compare these 4 samples and check them against all of the people above. Remember, and this is really key, bands can be missing in these samples of evidence here, but there can't be any extra bands in this lot. So no extra bands here. So if any of these have an extra band, they don't match the suspect. Anyway, good luck. Hope it doesn't take you too long. Okay, so this bit is an optional extra for anybody who's thoroughly enjoying the murder mystery at the moment and just wants to do a little bit more to try and work out what was going on. So what we've got here is a map of Worcester, and marked on this map up here as the recycling centre, this is where the bag for life went through the shredder, where they found the carry bag containing the blueberries and the baking soda and the remnants of the tire iron. And so we're going to try and use mobile phone data to work out whether any of our suspects was near the recycling centre at the time of the shredder going nuts. So what you may or may not know is that, let's say you're here with your mobile phone in your hand. Well, the mobile phone masts, and here's one, are constantly sending out signals to your mobile phone and back again so that your mobile phone is being connected. But what mobile phone masts often do is they often time how long it takes for the signal to get to your phone and back, and then they can work out the distance that you are from the mobile phone mast. And there's 3 mobile phone masts that were working well in Worcester at the time that the bag went through the shredder, and we've got the purple mast here, we've got the red mast in the middle, and we've got the blue mast on the right hand side. Now each of these masts can't work out the direction that the mobile phone is, but they can work out how far that phone was from them. So at the time this bag went through the shredder, we've managed to get data from the mobile phone company saying how far each of these people was from the various towers. So the ping between the tower and the phone and back again. Now it's not very accurate. It's only accurate to about 200 meters. That's the best it can do. So all of these are a little bit rough, but it gives us some idea of how far the suspects were, or the phones of the suspects were, from each of the mobile phone towers. And we can use this to work out who was near the recycling centre. So let me give you an example, and I'm going to use Chris, the victim, as the example case, okay? Because we're pretty sure she wasn't the one who was putting the tyre iron through the shredder. So this is how far she was from each of the towers. Now the first thing you're going to need to do is you are going to need to print out the map. You can work off a screen, but it would be quite difficult. So if you can, print off the map. And you've got a scale bar down here, which is 500 meters, and you need to measure how far that is as accurately as you can, certainly to the nearest millimeter. So for me, it turned out it was 2.0 centimeters. So I know that 2.0 centimeters is 500 meters. So how far is 2,400 meters on my map? Well, I know that 500 meters is 2 centimeters, so it's going to be around 5 times that. But I can be a bit more accurate than that. 2,400 divided by 500 is 4.8 times by 2 centimeters, and that gives us a distance of 9.6 centimeters. So this is where you're going to need a compass you're going to set the distance between the point of your compass and the pen to 9.6 centimetres, and you are going to draw a circle around the first mobile phone mast. Okay, so here we go. Around this mobile phone mast, we know that the victim, we know that, in this case the victim, we know that Chris, or her phone at any rate, was about 2.4 kilometres away, or 9.6 centimetres away. So then we look at the red mast, okay? Again, we know that 500 metres is about 2 centimetres, so this is about 1.2 times that. But more formally, 600 divided by 500 times 2 tells us that the distance from the red tower is about 2.4 centimetres. And again, that depends on how big your map is printed out. So whenever I'm multiplying by 2 here, you want to multiply by whatever distance you've got for your 500 metres. Anyway, we know that Chris's phone is about 2.4 centimetres from this red tower. And where the lines cross, here and here, this is where Chris's phone could be, roughly around that region. Now this is why you need 3 towers, because 2 towers will give you 2 different places where the circles overlap, where the victim or the phone could be. So we need the data from the 3rd tower, the blue tower. Here you can do this one in your head if you want. 2,000 metres is 4 times 500, so it's 4 times 2, or 8 centimetres, or you can just use the equation. So we again would need to draw a circle around 8 centimetres from the blue tower, and we will see that basically there's this area here where all 3 circles are overlapping. And remember, this is only accurate to 200 metres, so that isn't bad, but that's giving us an area where Chris's mobile phone would be. So I'm not suggesting you triangulate all these people. I'm suggesting that you look roughly, you try and work out who it might be just from rough distances, and then you go and you actually triangulate your suspects very accurately, and you try and work out which one of those was at the recycling centre. So just to recap the evidence to date, and this is all the evidence we've seen so far. A lady, later identified as Christina or Chris or Chrissy Killane, was found dead in a supermarket car park. On investigation of her house, it turned out that she was almost certainly a professional blackmailer. Looking through her items, we found out that these people were all being blackmailed by Chris for a variety of reasons, from shoplifting to dodgy photos to infidelity, insider trading, drink driving. The only person we weren't able to identify from the data is flip-flops. We went and we managed to trace that one of these 2 bags almost certainly was the one that went through the shredder with the tyre iron. And we thought that it was likely to be either the rower or Robin. Our suspicions for Robin were further confirmed when there appeared to be a note saying it was Robin that was floating around, had blown by the breeze across the car park. But in an interview with Robin, he had a receipt proving that he bought the salt. So clearly we hadn't matched up the shopping to the people from the CCTV completely properly. We know from Robin's receipt which bag he bought, and these 3 people bought their items with a credit card, so we're sure of what they bought, but that still means that there are 5 people who may have bought this bag. The bag with the blueberries, the water and the baking soda. Because the other option, the one with the blueberries, the vinegar and the baking soda, there's a receipt for that. So it was definitely this bag that did it. So here's the note. We looked at it in more detail. We saw that it didn't say it was Robin, but it was... Now, that might look damning for Paris, but unfortunately, that P could have been the start of a P, an R or a B, so Reg or Brittany also in the frame, as well as a couple of others. We can certainly say that the blood on the note was the victim Chris's, and we're fairly certain she wrote the start of the note because we found a few pens by the recycling board, and we found that the whiteboard marker which was used to start the note, actually these prints belonged to our victim Chris, but the note was finished with a Crayola pen. And yes, one of these prints matched the CSI tech, careless of him, but the other print matched Paris. So there's strong evidence that Paris finished off the note. This week, from some bloody footprints, you have worked out which suspect was the right height to have been around Chris when she died and walked through the puddle of blood coming out the back of her head. You have also hopefully identified some people whose hair was on the tyre iron. We would expect the victims, Chris, but who else's hair is on that? You've looked at some DNA evidence and you hopefully know whose blood was on the tyre iron. You've also hopefully worked out whose DNA was under the fingernails. And finally, if you've done this, you've hopefully done some triangulation to work out who was at the recycling centre at the time that the bag for life was thrown in the shredder. Putting all that together, you might be able to work out who are the most likely suspects. See if you can come up with the full story. What happened? Why did it happen in that way? Because if any of you get this right, or very close to right, and give me a full account of what you think happened, then I will release a bonus video where we will go and arrest the perpetrators, and then we will interview them to find out exactly how close you got to the truth. Happy hunting.